Well, welcome everybody to this last Meet and Learn in 2004. This is a series of Meet and Learn as organized within the Interreg-funded New European Bauhaus project ESSELT. Please see also the link that we're providing soon in the chat. I'm Dagmar Keim and I work in the City of Amsterdam at the Department of Urban Planning and Sustainability, and I'm project manager of the project. In this project, we look at the spatial challenges that we cities and regions encounter and try to find solutions how we can integrate the new economy into our cities. And we are focusing especially on the space. What is within this project, we explore a very wide range of themes like urgency, design challenges, business models, and value chains, like what we're looking at today. The concrete. What is special about this project is that we are not only looking at the cities and the regions, but also the interconnectivity between the different cities. And we do that within an area which we call the Eurodelta, which is roughly the area between Lille, Amsterdam, and the Ruhr area. We believe that this is a functional space without administrative boundaries. So today, I'm very thrilled that we have two speakers from the field of the practice. Lukas Arnaut, Managing Director at the Belgian company ResourceFull, who will tell us about substitution of cement with other materials. And Niki Loonen, a passionate advocate for sustainable concrete and advisor at TBI Holdings, who has a company in the harbor of Amsterdam. You will tell us about secondary materials. And since you are based in Amsterdam, you will also illustrate these aspects using the example from our city. So that's obviously very interesting for us. But you can translate this, I think, also to other cities. Important is the position of the harbor. Lukas and Niki, you will introduce yourself and also the work you're doing. And I ask you to also look into the spatial aspects. And we will look into today, especially as the secondary materials. Before we start, I have some housekeeping notes. We are recording this, so if you do not want to be recorded, please keep off your camera and change your name. This will be recorded on the Eurodelta website and on YouTube, also the presentations. And so we decided to have a presentation of about 15 minutes by Niki, and then some questions, and then Lukas, and afterwards some questions again. You can also put your questions already in the chat. So thank you very much. Niki, the floor is yours.
Okay, thank you. I will try to share my presentations. I will share some information about the opportunities for circular concrete. Concrete currently is a quite linear material, so we mine a lot of stuff, sand, aggregates, limestone, etc. And we make all kinds of ingredients for concrete for that. And I think that will change. It's already changing, and I will do my presentation on that. Let me first introduce myself. I'm Niki Loonen. I'm working for TBI. That's a group of contractors in the Netherlands for 4 months. After I worked for 25 years at an engineering firm as a geotechnical structural engineer in more the civil works, foundations, building pits. I'm also a lecturer at CO2 reduction at the Concrete Society in the Netherlands, and I'm an arbitrator for the Dutch Arbitrary Court for Construction. So I have some side jobs, but I'm mostly a consulting engineer for concrete mechanics, concrete technology, and geotechnics. I'm working on sustainable concrete now for 7 years, and I work very closely with the Dutch Concrete Accord. For example, I worked on the CO2 roadmap and also on Frontrunner report. And what did I do in the field? Also together with TBI in the past, we developed the use of alkali activated cementatious material in concrete. So a lot of cement replacement at our factory in Amsterdam at Voorbij. Arnaut will say more about this technology, so I will not mention that too much. We did a geopolymer slab in the harbor of Rotterdam together with the contractor Jeppe van Ees, who is also a TBI company. And we did postponed strength, and using only slag cement for higher performance concrete. And in the Netherlands, we have CROW, and that's that's a stichting, but it has. We do a lot of reports on how we can make concrete slightly different from the Eurocode, and there are several committees for that. And that way in the Netherlands we can go faster in making concrete more sustainable. And there's also some committees about secondary materials. My goal is to develop zero impact concrete. So I want to use as much secondary materials as possible, and I want carbon emissions to be zero, possibly even negative for concrete. I think that's possible. And last year in December, we made our first cube in the concrete factory in Amsterdam, which was CO2 neutral with a lot of technology and also a lot of secondary materials, and some of them will also pass in this presentation. The Dutch concrete, how circular is it at the moment? It's not so circular because most crushed concrete currently ends under roads or pavements or even warehouse slabs. The problem in the Netherlands is we don't have rock, so we need to find our stone somewhere else. And well, demolished buildings are obviously a good source for that. But it's a pity that we also put concrete in there because it's much better. It's more like a way of downcycling at the moment of the concrete, and we want to recycle the concrete into new concrete. That's also one of the goals of the Concrete Accord. So this is something we are planning to change. So the Dutch highway authorities, for example, are looking into the possibility to reduce the amount of concrete in the blended material, and even go to zero concrete in road foundations in the future. So so that's where most of our crushed concrete now is going, and that needs obviously to change, in my opinion. For comparison, if we look at glass or paper, the recycling percentages are 75 to 80%. So that's it should be possible to also do that for concrete, because almost all concrete is professionally demolished. So it would be even easier to do that when professionals are working on it than when it's only the public sector. Well, to crunch the numbers, in the Netherlands we use 12.5 cubic meters of concrete per year. We need 24 megatons of sand and aggregates per year, and we demolished 12 megatons of concrete per year. So potentially we could reach 50%. Currently we are at only 10% of the of recycling of crushed concrete. So we need to go from 10% to 100%, and then we can replace 50% of our sand and aggregates that we use. So we have a big step to make still. Well, what's already happening in Amsterdam? We have a city in city center. That's A. We have in B the industrial zone with the harbors, and in C we have new developments of housing in the Old IJsselmeer in het IJ. I will go into that. So what happens in Amsterdam is that some older buildings are demolished. It happens in older urban areas, and currently, as you can see, concrete and brick are crushed at the same time, and that needs to change. So we need to demolish the brick concrete. It's a little bit more work, but it's possible. But if we take out the concrete, for example, the foundations mostly are recycled to new concrete. We bring it from A to B. So the demolished concrete moves to the zone in the industrial zone where the harbors are, and I have some examples of what's happening. So the areas that have purple squares around it are situations where concrete is reused For example, in Renewy Amsterdam, you see a big harbor area that's allocated for the recycling of materials, and in the left you see the device that they have to crush and separate the concrete, and they are providing very high quality recycled sand and aggregates that can be used both in precast and ready mix concrete. And for example, very close by, so basically they are neighbors, the concrete crusher and company Voorbij Precast. So Voorbij Precast is using the aggregates and in the future also the sands of the crusher in new concrete. So 50% of the aggregate that's used in the picture on the left is already crushed aggregate, and we are working on also replacing 30% of the sand with sand that comes from the same crusher. So that's it's already happening that the concrete that is demolished in Amsterdam is processed in a waste plant and is used in a concrete plant in Amsterdam. Other places where the crushed concrete goes is the ready mix companies in Amsterdam, the ready mix plants, and I show 3 of them that are also in the same area. So the distances of travel from one place to another is very minimal, which is also a big advantage. If we use sand and aggregates, it sometimes has to travel hundreds of kilometers, and if we use recycled materials, these transport distances are only a few kilometers, so that's a lot less travel. A special factory is Rutte Group. It's a little bit outside the industrial area at the other side of the canal, but still it is very close to the city. And this is a smart crusher. So on the left picture you see what happens if you normally crush concrete. You get some concrete chunks. Rutte Group has technology, Urban Mind Smart Crusher, and you can see on the right of the picture that it provides a relatively clean aggregate, a relatively clean sand and concrete fines, and they do that in their factory on the right. And they don't only collect the concrete and recycle the concrete, but they also produce precast concrete and they produce ready mix concrete. But then they still have material left, and they also spread that over other manufacturers in Amsterdam. So this is a really interesting technology, because with this technology you can reuse in new concrete 100% aggregate, 60% sand, and I think 10 or 20% concrete fines as a cement replacement. So and yeah, we will see more of those factories in the Netherlands soon. One thing that's special when you recycle with a smart crusher is that the concrete fines come back to you, and in this case they are working on technology to bind carbon, so CO2, in the concrete fines. So this is one way that concrete can become a carbon sink, or there's other technology which can be used to recycle the concrete so it will become a binder again. And Rutte therefore works together with Heidelberg Materials, which is a cement producer. So so the recycling of concrete gets better and better with it's still not upcycling, but better recycling than traditionally. So now it's processed in the zone B, and what happens then is that the best is to bring it as close by to C. So a lot of new housing is built in Amsterdam. For example, here in Eiburg. This is an example of a project in Eiburg, which is a claimed land from the old sea, which is now a lake because of the dike in the north. And with recycled concrete, we can make very special buildings, like you see here, which is also located at the port at the west side of Eiburg. It stays in Amsterdam. So the concrete that's demolished in Amsterdam is processed in Amsterdam, and it stays in Amsterdam. And you can make obviously fantastic buildings with it. So how can we stimulate the reuse of concrete? It's important that separate demolishment will be prescribed in permits, in demolishment permits. Currently, it's not prescribed. So the demolishment concrete contractor will use the cheapest way of demolishment. And yeah, well, the cheapest way of, for example, demolishing a car is throwing it in the river. But we are also not allowed to do that. So why are we allowed to not separately demolish concrete? So that's something that local municipalities can arrange and look after. There should be more space for storage and processing of demolished concrete, because there's always a lag, and you need to have stored materials prepared to use it. In normal sand and aggregate, that's not so much necessary, because you can store it outside the city, or you can just produce a little bit less or a little bit more. And when you use demolished concrete, you have some time between demolishment and using it, and you need some time for processing it. So there needs to be more space for the storage and processing of demolished concrete. There should be a ban on crushed concrete under roads and warehouses and pavements, which we are working on in the Netherlands, but that should be maybe also the municipalities. If they build a road, they should state in their contract that it's not allowed to use crushed concrete, or at least less concrete in these foundation layers, which is possible. And it should be mandatory to use crushed aggregate crushed concrete aggregates in new concrete, and that can also be arranged in several ways, but especially when the municipality is the client that buys the concrete, they can ask for it. So yeah, if we do all this, we can create a new economy with circular concrete. Thank you for your time.
Thank you very much. That was a very good short presentation, to the point. Thank you. I would like to open the floor to some questions. Maybe you can stop sharing.
I will stop sharing, yes. Peter Paul has a question.
Yeah, Peter.
Yeah, thanks for the very interesting presentation. The discourse at this moment for speeding up housing is to limit the enormous amount of rules, which makes it quite complicated to in cases of many to speed up the building of housing. In the end of your presentation, you had 4 recommendations, and 3 are about adding some rules. So the separate demolishment of the materials, the ban of using crushed material below roads, and the mandatory use of, don't remember the last one, but you are talking about adding 3 rules to speed up this use of secondary concrete. So these are 2 different discourses. Can you say something about it? Because you are working at a construction company,
yep.
And the discourse is particularly from private parties. They are quite lobbying to the national government. Please limit the number of rules. But on the same hand, you also hear this loud voice on, if you want to make much more circular construction, please come up with some clear rules. Maybe you can react on this.
The big issue is that it's that there's no real incentive on using recycled concrete, because it doesn't decrease the MKI value of concrete. So the environmental impact of concrete is not lower when you use secondary aggregates instead of primary aggregates. So that incentive is not available. And the cost of mining sand and aggregates is so insanely cheap, because the damages made by this industry are not paid for. So it's basically, you can get the sand and aggregate for free out of the soil. So there's no, if you would, and the best solution would be pay a tax of 10 euros per ton on mining of sand and aggregates. then sand and aggregates get 10 euros per ton more expensive, and the secondary materials therefore get 10 euros per ton more value, and then everything will be arranged. So that there's different ways to do it, but currently it's cheaper to mine basalt in Norway, ship it to Amsterdam and use it than to recycle concrete. So there needs to be another incentive. And you can think of many possible incentives. You can also say the state will pay the ones that reuses the concrete 10 euros per ton. So you put in a subsidy, you put in a tax on linear material, you put in regulation. But if you do nothing, nothing will happen, because contractors will be on the money, and developers also.
Yeah. So rules are needed to get a good business case.
Yeah, absolutely.
Thank you.
Alexander.
Santos. Sorry.
Yeah. Thank you for the great presentation. One question I was wondering is the recommendation on more space and storage for the processed material. Where would it make it more sense to store it? In B, in the harbor, or in local distribution centers? What is more efficient, basically?
The best location is B, because you cannot store it in the city itself, and you want the distance between the place where it's demolished, the place where it's processed, and as close as possible. So somewhere in the harbor of Amsterdam would be the most convenient location. Maybe the harbor needs to be extended, but for example, there's a big coal distribution site in Amsterdam in the harbor. That one is closing, and of course many industries are looking for that area, and I would recommend to allocate such an area for the sustainable industry and not for some new petrochemical or which maybe is willing to pay more money, because there's more money to be made with petrochemicals than so you can store diesel there if you need more diesel, but you can also store concrete there. I think storing diesel, for example, will make more money, so they can pay more rent. But the question is, what do you want to incentivize as a city?
Thank you. Very interesting.
Yeah, maybe one question that we've been visiting your plant together with some students from the RWTH Hagen in this project, and it is very big. Your company, together with a company next door, Renewy, who is recycling and crushing the materials, and I measured it on it's like 1 kilometer so together, and maybe 250, 300 meter broad. So it's a huge area, and this is for what kind of percentage? So I'm wondering, like, how many of these companies would we need in the city of Amsterdam, and how many of these Renewies would we need to solve this problem?
Yeah, currently we only reuse 10%. We want to go to 80%, so you would need 8. But that's maybe a little bit. You don't need you don't need 8 times the area, but you will significantly need to increase the capacity of those factories. For example, at the Voorbij factory that you saw also in the presentation, we have less than 1 week of storage of produced product. So everything we produce is on average less than a week on site, on the production side, and that's already just in time delivery. And we need the same amount of aggregates that we need to produce the concrete. And for the aggregate supply, you need more times of storage, more weeks of storage, because if there's for example less demolishment in a month, we still need to feed the concrete factory because it needs to run. So you need more storage for the source material than you need for the produced material. But it's obviously that if we want to scale this by a factor of 10, we need especially more space for the demolishment, for the stockage of demolished concrete and processed demolished concrete. But at least 3 times, I think.
Yeah, thank you, Alexander.
Yeah. Thank you, Niki. And apologies, I came 5 minutes late. So if my question was answered in your first slides, then
No
sorry
problem.
for that. I'm curious about two things. The first thing is, how is the different materials transported between the locations? As they're in the harbor, are you still using trucks, or is over water also an option?
If it's local, it's trucks.
It's trucks, right? Local is trucks. Okay. And then the other thing, because you just said, well, you need extra storage, and this storage is kind of is variable, depending on demand and supply and so forth. So, is it also possible to think this temporarily? So in sense of on water in large boats, or is that making it very difficult if it's not on the?
Yeah, the waterways are not that deep, so basically you can stockpile much higher on the soil than you can stockpile in a ship. It's really it's really heavy material. So and you don't have in our waterways in the Netherlands they are not deep. So
I'm talking about because you're in the harbor. Huh? The part of the harbor you are is deep. If I'm not mistaken.
Yeah, that part is deep.
That part is deep. So
the parts that are deep are the waterways where the ships go, and so you cannot block that.
No.
And you also
I was thinking about
and the case you can also not block.
Yeah.
You cannot block the case.
Good, thanks.
So that's.
But why do you need to be a harbor then? Why does it need to be in the harbor? Can it not
for
be
example,
anywhere?
for the at least for the precast factories, they also get in aggregates from outside, for example from Norway and Scotland, and that all comes via ship. And also for example Renewy, they when they have too little amount of crushed concrete from the Amsterdam city, they ship in. So Amsterdam uses more concrete aggregates than they produce. So if from other locations they ship in material, and of course if you're not at the harbor, you can ship it in and then truck it to another location for them. But it's convenient to be at the waterside when you use so much aggregates. So you try to do via ship what's feasible via ship because it's cheaper and more sustainable, and what needs to, and if it's less than 20 kilometers, you truck.
Okay, and so your story sounded like you could solve everything on the scale of the city, but we are here looking for the interconnectivities on a very large scale, the Eurodelta, maybe that's a too large scale. But we chose that because you also have areas like crimpage areas, a lot of transformation areas where we think a lot of concrete comes free.
Yeah.
And you just also said the city of Amsterdam is using more than we are producing.
Yeah.
Do you think
Amsterdam is growing in absolute size?
Yeah. So do you think that there is a connectivity that we should explore and that would help all partners to accelerate the transition?
Yeah, if you have cities where more concrete is coming from, you can transport it via ship on canals or even via the sea. And you can collect from the areas that you are connected to via the waterways. You cannot. It's not feasible to transport aggregates for further than 20 kilometers over road. That's not so. That's where the waterways, and you of course you can bring from one city to another to meet supply and demand.
Would be rail an alternative?
Yeah, that could be for let's say a few hundred kilometers. That could be an alternative. If it goes over 500 kilometers, I think that will also not be comparable to ship. But 200-300 kilometers, I think, would be possible on rail.
We have one question also in the chat.
Yeah.
I have not opened the chat.
Lindy, she's asking focus on keeping the concrete recycle process within Amsterdam on the regional level for Eurodelta. Is there currently much consideration for collaboration for recycling process across borders within Germany and Belgium?
I know in the Netherlands we import already crushed concrete from other countries. So because in the Netherlands it's used more than for example in Germany, it's not yet very common to use it, only from own production in concrete plants, but not from demolishment. not so much, at least in the Netherlands. So we when there's a big factory being demolished and they can't put the concrete on ships, they bring it to the Netherlands. So that's already happening. Maybe we should go through to
yeah, that was
Arnaut.
my suggestion. Now we go to Arnaut.
Yeah.
Arnaut, are you ready? Yeah.
Yes, I am ready. I hope you are ready as well.
Yes.
Right. So I will share my screen. All right. So as a add-on to what Niki all told before, I will zoom a little bit more in on another kind of waste, being waste from the metallurgical industry, and how we can use that in concrete, and then more specified on how we can replace cement with that. I'm Lukas Arnaut from the company ResourceFull. We are a concrete and mortar lab specialized in the development of low-impact building materials, currently working with 17 people based in Ghent in Belgium. Why do we choose building materials to work on it? Why is that our mission, to make them green? Well, the whole building operations, building materials together are responsible for 50% of the CO2, man-made CO2 exhaust. And then the mainly used building material is concrete. It's so enormously used, 13 billion cubic meter per year. If you cast that over Belgium, that's a layer of 40 centimeters of concrete every year, again and again. I also calculated it for Holland. It's 28 centimeter. It's still also quite a lot, let's say. So that's an enormous volume of material that we are using. And that's also immediately the explanation why it has such a high footprint, because ton per ton, concrete is also by far one of the best building materials to use, but it's a bit the victim of its own success. Concrete, we make it by mixing cement and water, gluing together the sand and the stones, and it's this 15% weight of cement is responsible for plus minus 90% of the unreinforced concrete. And the cement has a high footprint. Maybe you know some of this stuff already, because we start with limestone, calcium carbonate. It's a calcium and a carbonate molecule bounded together. We put that in a big furnace together with some car tires and coal and whatever to produce clinker, the active mineral in the cement. And like that, we produce 900 kilo of CO2 per ton of clinker. Is that a lot? In fact, no. If you make steel, it's more 2.5 ton of CO2 per ton of steel, and primary aluminium, for example, can be up to 15. So ton per ton, cement is already on the low side. And then we don't even talk about concrete, where we use so little cement per cubic meter. But because of the production volume of 4 billion ton per year, and that's going to rise towards 5 or 6 billion ton per year by the year 2050. The material is responsible for 8 to 10% of the worldwide CO2 emissions. To give you a little idea, that's about 4 times more than all the airplanes the whole year in the world. If cement would be a country, it would be ranked United States, China, cement, Japan, something like that. Cement only is really a very high emitter. So we have to do something about it. This is a graph made by Samburo, the European Cement Association. They have a lot of strategies to bring that number down by using different fuels, different input materials in their furnace. A lot of the money is put in carbon capture, carbon storage, carbon usage. These strategies, but that will cost a lot of money. We estimate that cement will cost 250 or 300 euro per ton by the year 2030, which would be a doubling in price, which will be very expensive to build. So what are we doing here in our company? We try to substitute clinker as much as possible, to the largest possible extent. With which materials are we trying to do that? We are doing it with calcined clays and these kind of materials, the virgin raw materials, but also a lot with waste materials from other huge industries like the metallurgical industry, the ones who make steel, lead, zinc, copper, and all that kind of minerals. They are having a waste problem, like you see here, for example, in Hungary, red mud, here mountains of slag. But next to that, there are still a lot of other materials that can be used to substitute clinker cement in a small way, 10-20% up to fully clinker-free cements. It's not me who is saying that. There are smart professors writing papers about that there are billions of tons of materials in the world available to do this. It will never be the perfect solution, and we will always need Portland cement, but the more we can avoid it, the less CO2 we need to capture afterwards, and the cheaper the building materials will be in the future. Here you see that fancy graph from a paper. You see it on a table, and this is actually a table in the lab of ResourceFull. These are more than 70 secondary raw materials that we are actively working on in our company. From dredging waste from the harbor of Rotterdam, milled bricks from houses, mineral wool from insulation. This is one material that Niki also talked about, the cement dust from breaking operations, steel slags, lead slags, copper slags, and so forth and so further. Our specialty, I'm a metallurgical engineer by background, is slags, metallurgical waste. Why is that? It's a little bit historical and local reasons. We have 3 steel plants here at the sea, 2 of ArcelorMittal, 1 of Tata Steel in IJmuiden. In the Campine region, the Kampen, Antwerp region harbor, we have a lot of non-ferrous metallurgy, lead, copper, aluminium, zinc. And in Wallonia, we have a lot of stainless steel and steel. So locally, if you add up all these slags, we come up with a number 6 million ton of slag available in Belgium on a Benelux cement market of 11 million ton. So globally, that ratio is a bit different, but here locally Benelux, we have a lot of these raw materials available to more or less replace cement, which could really be, in Dutch we say, a slok op de borrel. What is slag? Where does it come from? Very shortly explained. When you take a mineral, an ore, an erts from a mountain, you bring it to Belgium, you mill it, you put it in a furnace, but in an average copper ore, for example, refined already, there is 20 to 30% copper, which means you still have 70 to 80% other materials, stones, sand, which also melt in your furnace. That floats on top of your metal, a bit like oil floats on water. And what do you have to think about slag? Slag is like magma, like lava coming from a volcano, which now we just throw it on a mountain, but if you treat it right, you can make it into a reactive mineral. Is there enough slag? This is, for example, a movie from ArcelorMittal in Ghent, where every year they fly with the drone over the mountain of steel slag to see how much they collected. And currently they have a stock of 3 million ton of steel slags, for example. So we are actively trying to recycle that from wastes into high added value building materials, from slag to stair. That's a little bit the mission. We do that through our 5 departments to mill the slag, to analyze what is inside, can we remelt it? Then we try to design a new cement with it. If we have a new cement developed by geopolymerization, by CO2 carbonation, and so forth and so further, we try to design products with it, concretes, 3D printing, mortars, and so forth and so further. Then we look at the long-term performance of concrete, because the new concrete we design should last at least as long as the current concrete. Otherwise, it's a stupid invention. And then we like to implement it in the real scale. So here you see, for example, how do we start? We try to teach these guys, treat your slag like a product, change it upstream, change the chemistry, change the cooling rate. Then we try to do that in a larger scale, where we then make pilot batches of these materials. And here you see, after the whole lab development, I show some pictures of things what we have implemented. For example, ultra high performance concrete without Portland cement, purely based on lead slag and blast furnace slag, activated with potassium silicate, for example. The same kind of binder was then used in the design of a C90-105 concrete basalt fiber reinforced for these big concrete sandwich panels to be installed in industrial buildings. And here you see, because it was a fiber reinforced strong mix, we could even reduce the outer layer to 2 centimeters rather than 6. So we could also store more of these panels in a truck, also lowering transport cost. We did the same with blast furnace slag, where we are now putting a whole brandweerkazerne, what is it, fire truck building, with these kind of materials. We are making clinkers and pavers and grass tiles with it, with a more classic geopolymer system. You know, if you mix the slag with water, nothing happens. You need to bombard it a little bit with stronger chemicals to make it react. And here you see it was a mix of stainless steel slag and blast furnace slag, where we put 1,000 square meters of these pavers in a new building. We are making sewage pipes with a combination of slag and fly ash. Here we in fact have a double win. We get out all the Portland cement, so cube per cube we have a lower footprint, but the geopolymer is also more acid resistant against the biogenic acid attack in the sewage pipes. So we also have a double lifetime, which is we kill 2 flies in one slab, or how you say it in English. We make hollow cores. This is a little bit more advanced pre-stressed concrete. Here we are doing the pilot trials, but this requires longer time towards implementation with these new kind of binders, because we have to study creep and creep relaxation, shrinkage, corrosion resistance of the cables. But of course you have to start the investigation now. By the time we can implement it, you start now to maybe implement it in 3 to 5 years. 3D print mortars is also a little bit, it is a bit a hype in some material and some products. I think we believe in it, but if you 3D print, you should do it, let's say, with a eco mortar, because in the average 3D printing mortar, there is 600, 700, 800 kilo of Portland cement. Yeah, then the people who claim that they can use a little bit less material, yeah, but in an average ready-mix concrete, there is maybe 100 kilo of clinker. Yeah, then you already need to use a lot less material to be more eco-friendly. This was then further fine-tuned into a self-compacting geopolymer add water only, where we produced, I think, 120 cubic meters of blast furnace slag activated, which we put as the foundations in a new building, and we are now monitoring the quality over time. Here was the first time ever we really built something structural. This was this hybrid concrete, something Niki also implemented in TBI, I believe, in Voorbij Prefab, the time he was working in ABT, very similar mix, where we can reduce the amount of clinker to a very low amount, but still have a demolding time of 16 hours, 20 hours, okay to turn in prefab companies. We put some footpaths in Ghent, where we made a clinker-free geopolymer, but 50% of the sand and 100% of the gravel was replaced with recycled concrete sand and recycled concrete stones. Also what Niki showed before, and he is right. When you use recycled concrete stones, it doesn't change the MKI score of your concrete. But if you can combine it with a geopolymer, maybe we have a bit even the best of both worlds. And here is my wife inspecting the concrete quality. She was not as impressed as I hoped. Well. Then with copper slag, this is, for example, a material that is currently still dumped somewhere. Rubies, who has a big plant in Beerse, asked Hood, we are building a new warehouse. We want all the concrete to be made with our own slag. We walk the talk, let's do it. And we designed for them a beautiful pumped concrete based on copper slag, which was then polishable after a few hours on a windy April day. And it still looks good, up to date. And they liked it so much that we could even go up higher, one environmental class. And now we put 2,000 square meters of copper slag based concrete in the outside space, the scrap yard of our rubies. Here, this place is the big copper furnace where the slag comes out. And at the same part, we show that with the waste, we can do something beautiful. Brick slips baked clay has also a very high footprint, although it's not known for that, but it has a higher footprint than concrete, for example. And this is, for example, something that can be implemented quite fast because it's not structural, not reinforced, and so forth and so further. Self-leveling floors, a little bit the same decorative layers, but we get out all the Portland cement and we do it purely based on steel slag. Yeah, then it has some other requirements. And as the last slide, for example, here we're also working on a dry, non-structural, non-reinforced layer, smeervloeren, dry screeds without clinker. In the average cubic meter of dry screed, there is more clinker than in the average cube of ready-mix concrete, which is, in my opinion, totally stupid. So if we cannot innovate in these products quite fast to lower the footprint of the building industry, then it will not work in any kind of product. So this was in a gallop tempo a little bit, some introduction to new kind of cements in addition to what Niki already told us before.
Yeah, thank you very much, Lukas. This really shows how it's more than just the aggregate and the cement, which obviously, because so much volume we always think about, but the cement and the chances in our area, I think, are quite high to do something. Are there some questions? If not, I might have a question myself. I understood earlier that when you, I think with steel and so, it's obviously we read it every day in the newspaper. The two things: the CO2 emission, and that it will be there will be more and more water, hydrogen used for the steel production. And I understood that then you will have no slag or other kind of slag. So this would be one thing I would like to know. And also, we are now thinking that many of these companies will close. So what would be effect on that?
I will. I think I have a slide on that. Yeah, here I have it. I will explain. This is how currently in IJmuiden, in Ghent, and in Duinkerke, the three closest steel factories, how they make steel. You start with a blast furnace, the hoogoven, where you throw in your iron ore, your flux, and your coal. Here, the transition from iron ore to liquid iron is happening. And 90% of the CO2 emitted during steel production happens in this furnace. And this is the furnace that locally by 28 and 29, the factories ArcelorMittal and Tata will start breaking down. Because this in Ghent, for example, they have 2 of these furnaces and they are responsible for 6% of the total Belgian CO2 exhaust. So these are the ones they are breaking down. Then you refine it further and even further to make steel. These furnaces will always keep on existing. That's the slags that we are working hard to recycle. Here, this is a problem. The blast furnace slag coming from this one, it's currently super widely used in the Benelux. That's why we have the lowest footprint, the lowest concrete footprint of the whole world. but locally the availability of this material will be gone. So that is a challenge. But they will replace these kind of furnaces with other furnaces. So we're already working now together with the steel companies to see what kind of slag will come out of the new hydrogen furnace that will replace this one to make it suitable for the cement. And we are working hard on the recycling of the EAF, the converter, and the ladle furnace slags to compensate. This is a little bit the story. And indeed, that story is only valid if they still exist in a few years, and we don't let them not get killed by cheap Chinese steel. That's for sure true. Yeah.
Thank you. Alexandre.
I was also had a question on stability of the materials, but also on their acceptability. How is it going? And do you think it will be easier to commercialize them, or is that an issue?
No, I believe it will work because at a certain point they will be cheaper than normal cement, and they are one of the easiest ways to already lower the footprint of concrete. There are two things. You have the environmental point. So first thing we do is check what is inside. Are there heavy metals? Is this a material that is safe to use? Or can we, by using it in concrete, can we immobilize these metals so that it becomes more safer than just dumping them? But this is the law. If you are above the leaching limits, you can go in jail to do it. So that's obliged. That's the first thing we look at it. Then you have the more voluntarily rules, which are like the Benor, Kiwakomo kind of rules on concrete. And that's why I showed we are working on pre-stressed structural concrete, which will take a very long time. We are in the Belgium Norm Commission to write new norms on new cements and so forth and so further. But that's why we're also working on dry screeds and pavers and stuff like that, lower liability products where we can accelerate innovation much faster. That's a little bit, my answer to that. Yeah.
Thank you.
Thank you. Frederik, you raised your hand, you put it down. You still want to ask?
Because I had the same question. I was also wondering how in Belgium they are working with the rules, of course, and the regulations and the rules of the Eurocode, where the definition of concrete is, of course, stated what concrete is, and now you're using different materials. And what your view is on that, because you also need, of course, how do you say it, acceptance to start building. And how did you do that? For instance, for some of the projects, how did you manage to get that done?
Well, for certain products, it is not needed. For example, for the sandwich panels, we are placing them en masse in the buildings because it's the non-structural outer layer that we are using, where there are basically no questions asked. It has to be good quality, but we tested them, and CRH, our partner, says they are good, and we just implement it. For a pre-stressed beam, there we will have to be within the Eurocode too. So we are either, on one hand, doing the long shot, we are trying to write new norms for new binders, for which these new binders we will make new concretes, which fall under the EN 206, which should then be okay according to the Eurocode too. But in Belgium, you have a little bit something, you have the Belgium equivalent of a ETA is the ATG, Algemeen Technische Goedkeuring, what is a general technical acceptance, where an expert committee is looking at your development, and they can give an okay to that. They give you a dossier in ATG, which is equivalent to Benor concrete, for example, and then you can also use it. And for example, in the hollow cores, this could be a good option because this can be made with design by testing, where every day you cut a piece, you break it down, and it's okay, you can do it. But for more complex, everyday different beam, that will be harder. But there is no one answer to that. It's from every specific concrete product has its own liability, regulation, risk, costs, and so forth and so further, and it has to be tackled in that. But it's a spider web of regulation, that's for sure.
Thank you very much.
Yes, thank you so much. Unfortunately, this time I wanted to ask you about the spatial question and also the role of cities and regions. but maybe we can discuss this in the after talk. Or you want to say one thing? What would be the role of the cities and regions in your process, or is it something that you as companies just do with you?
Yeah, well, for example, that staircase that we built was in the city of Ghent. They acted as the bouwheer, as the landlord. They put SECO, which is a certifying body, in the process, and SECO looked at our technical file. They said, it's okay, this is good concrete, you can use it. So we were outside of the rules, but we were able to implement a structural material. And now the rule in city of Ghent changed. Every stadsmeubilair made from concrete has one rule inside: maximum 150 kilo CO2 emitted per cubic meter. And people who cannot deliver are not allowed. So they created customers, because now we are making 200 cubic meter of architectonic benches for the city. Other customers call me, hey, I saw this rule in the city of Ghent, his public bestek. Can you help me? So that's actually a very nice rule that cities can play. They order a lot of concrete. If they can just say, we don't want concrete with more than 150 or 100 kilo CO2, it will open up the market. And I think they should do it, because they pay these things with public money, and it's good for the public to do it. Yeah.
No, thank you very much.
Even more rules.
Yeah, even more rules. The rules are piling up. Okay, that's another question. That's a role for us to make that handle, to make this good. Well, thank you very much for this very insightful talk. I would like to say to everybody, enjoy your beautiful day today. At least here in Amsterdam, the sun is shining. And have a nice weekend. Bye-bye.
Thank you very much.
Thank you.
Bye-bye.